Hello students, welcome back to the ninth video of this playlist. So in this video, we will be solving question number 9 from January 2024 Pure Mathematics 2 paper. So let's see what's the question number 9 from this paper is about. Okay, so question number 9, concepts behind question number 9 is from trigonometry and trigonometry and trigonometric identities that has been discussed in chapter number 6 of your pure mathematics 2 textbook. So in order to be able to solve this question, definitely you should have clear idea about trigonometric functions, identities, and how to simplify trigonometric equations, and also idea about the cast diagram. So, and besides that, we also need some concept of graphs and transformations in the second part of this question. So let's get started with question number 9. Part 1. Solve for x greater than or equal to 0 less than 360 degree the equation sin x tan x equals 5, giving you answers to one decimal place. Okay, so we need to solve this trigonometric equation. Okay, sin x tan x equals to 5. So part A, sin x tan x can be written as what? Sin x over cos x equals to what? 5, right? So sin x, it becomes sin squared x over cos x equals to 5. Okay, now cross multiply. So you will get sin square x equals to 5 cos x. So sin square x can be written as 1 minus cos square x, isn't it? So 1 minus cos squared x equals to 5 cos x. So take all the terms to the right side. So you'll get cos squared x plus 5 cos x minus 1 equals 0. Okay. Now, how we can solve this quadratic? This is basically a quadratic equation, isn't it? So use the quadratic formula. Negative 5 plus minus b squared is 25 plus 4. This is square root of 29 over what? Twice of a. Okay. So one of the value for cos x is positive and the another value is negative. So since what? The range of values for x is given, x is greater than or equal 0 degree, less than or equal 360 degree. That means we know that in two quadrants in the cast diagram, isn't it? In two quadrants in the cast diagram, cos theta is what? Positive. Where? The fourth quadrant and the first quadrant. So you will have four possible values for x because the value of cos x is both positive and negative. Okay, so four possible values at four quadrants. So consider for the positive one, cos x equals to negative 5 plus square root of 29 over 2. You will get what? X equals to, use your calculator. In your calculator should be in degree mode. Okay, sorry. So your calculator should be in degree mode. So negative 5 plus square root of 29 over 2. So cos inverse answer, that would give you 78.896, something like that, degree. And another one possible value is 360 minus the answer you got, acute angle. Okay, the principal angle we got, this is 78.89. Use this principal angle to get another possible value here, which is 360 degree minus theta. Okay, so why we are considering the fourth quadrant, why not the second or the third? Because the value for cos x is positive and cos x is positive in the fourth quadrant. That's why we are considering the value of theta in the fourth quadrant. So So 281.10 something degrees, and then cos x, the negative cos x value, square root of 29, negative square root of 29 over 2. For that one, the possible values for x are negative 5, negative square root of 29 over 2. So cos inverse answer, that would give you negative 5, negative square root of 29 over 2. Oh, okay. So negative 5, negative square root of 29, for that you will have no possible values for x because it is greater than 1. And we know that the value of cos x is always what? Less than 1 and greater than negative 1. So we can ignore this one without any writing any reason, no problem. So the possible values for x, that is solution to the given trigonometric equation, is basically what? To one decimal place we have to write it, that is 78.9, and the other one is 281.1 degree. Earlier I said four possible values for x would be there, but I didn't consider that negative value was less than negative 5. Negative value was less than negative 5, that's why we have to ignore it. So the answer would be there would be two possible values for x, and that's the solution to the given trigonometric equation in question number 9 part 1. Okay, next is part 2. So in part 2, right at first you can see a figure 1. Figure 1 shows a sketch of part of the curve with equation y equals to a sine 2 theta minus 3 pi over 8 plus 2. Okay, where a is a constant and theta is measured in radians, the points p, q and r lie on the curve and are shown in figure 1. So we can see in figure 1 the 3 points p, q and r. Okay, given that the y coordinate of p is what? 7. The y coordinate of point p is 7. Now part A asks here to state the value of a. We need to state the value of what? A. So we know the y coordinate of point P, right? And point P is basically the maximum point on this graph of sine theta. So basically this is a transformed graph of sine theta. Okay, since this is the maximum turning point, so at maximum turning point the value of sine theta is what? 1, right? So at P the value of sine theta would be what? 1. Okay, so what we will consider? Okay, so at P the value of sine theta is what? It's the maximum. So maximum value of sine theta is what? 1. Fine. So we know the y value for point P, right? So part 2, this is part 2a if I'm not wrong. Part 2a. Okay. So for part 2a, at P the value of sine theta will be what? 1. So a plus 2 equals to what? 7, right? A plus 2 equals to 7. Therefore the value for a would be what? 7 minus 2, which is just 5. That's the value for what? A. And that's what part 2a has asked for. That's it. Okay, next is part B. Part B asks here to find the exact coordinates of Q. So exact coordinates of point Q. So we need x, the value for theta, and also the y coordinate. So we can see that point Q is basically the minimum point on this curve, right? This minimum point on the curve will be occurring when the value of sine theta, that means this part, the value of sine theta is what? Negative 1. Okay, so we know the value for a, which is 5. So 5 times minus 1, this is negative 5. Negative 5 plus 2, which is negative what? 3. So at Q, the y value is what? Negative 3. Negative 5 plus 3, yeah, negative 3. Okay. Now, we need the value for what? Theta, isn't it? Okay. So, since we could figure out the value of y at point Q, so using that we can easily figure out the value for theta, right? So for part B, what we can write is that at Q, y equals to 5 times what? Negative 1. Value of sin theta will be minimum negative 1 plus 2, which is negative 3. Okay, we got the y coordinate of point Q. Now equate this. So 5 sine but 2 theta minus 3 pi over 8, if I'm not wrong. Let me check it out. 3 pi over 8. Okay, 2 theta negative 3 pi over 8. This is plus 2 equals to what? Negative 3. Okay, so we could directly consider sine 2 theta. We would not need to consider the whole equation because we are just dependent on the value of sine theta here, right? This is negative 1. You can get it from this equation also, but we could do it directly. Okay, so 2 theta minus 3 pi over 8 would be sine inverse negative 1. Okay, let's see the graph. Sine inverse negative 1. So point Q is the first minimum point on the graph of what? Y, on the sketch of Y. Okay, so the first minimum point occurs at where? The first minimum point occurs in the graph of sin theta is at sin 0 degree is 0, 90 degrees 1, 180 is 0, 270 is minus 1. So that means 270 degrees is what? 3 pi over 2 radian. Okay, so 3 pi over 2 radian. So let's figure out the value for theta. What you will get, 2 theta equals to 3 pi over 2 plus what? 3 over 2 plus 3 over 8 would be 15 over 8. Okay, so 15 over 8 pi radian. So the value of theta would be what? 15 over 16 pi radian. So point Q is what? 15 over 16 pi radian, and its y value is negative 3. Negative 5 plus 3, yeah, negative 3. And that's the coordinates of point Q, and that is what part B of 2 question number 9.2 has asked for. That's it. Okay, next is part C of question number 9.2. Okay, part C is asking to find the value of theta at R, giving you answer to 3 significant figures. Okay, let's see the figure. Point R is basically where the value of y is 0, right? It lies on the x-axis. Okay, fine. So that means we will just equate the value of y as what? 0. In the equation, we will just put what? Y equals to 0 and then solve for theta. Okay. So for part C, at R, the value of y is what? 0. So what we can write? The equation is 5 sine 2 theta minus 3 pi over 8 plus 2 equals to 0. So sine 2 theta minus 3 pi over 8 equals to negative 2 over 5. Okay, now we need to see the figure 1. Look, so point R is basically what? This is the first point where the curve is intersecting the x-axis. This is the second, this is the third, and this is the fourth one. So fourth one would be the value for the theta at R. So what did I mean by fourth value? Basically, when you will be considering the value for sine theta, okay, when we will be considering the values of sine theta here, values of theta basically using the cast diagram, okay, we need to have concepts from cast diagram here. So we will see many possible values for theta, okay. So in the sequence we need to approach so that the fourth value would be for theta. Okay, let's see if as we do the workings we can understand better. Look, so we need now what the cast diagram. So for what 2 theta minus 3 pi over 8, it's what sine inverse negative 2 over 5. So sine inverse negative 2 over 5 is negative 0.411. Okay, so it lies where? Here, because value of sine theta is negative, CAST, and in the fourth quadrant the value of sine theta is negative. Okay, so this is basically the principal angle. Okay, the positive, if you consider the positive of this one, this will be the principal angle. Okay, principal angle is basically the angle which we will use to consider the value of the sine theta at different quadrants, and using that value of sine theta we will find out the possible values for theta. So the positive of that principal angle, positive of negative 0.411, this is basically the principal angle, which is positive 0.4115168.461. Okay, so now we will consider the possible values for theta in the sequence of point R. Point R is the fourth one, right? So the first possible value for theta we got negative 0.411. Let me take the exact value, 5168.461. Okay, okay, this is the first one. Okay, now the second one is positive 0.411. No, positive 0.411 is not acceptable because the value of sine theta should be negative. In the first quadrant the value of sine theta is not negative, it's positive. So in the first quadrant not possible, in the second quadrant not possible, but in the third quadrant another possible value for theta. Okay, which is pi plus 0.3.1416 plus 0.411 dot 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 something. Okay, so this is 3 point, oh, this is 3.55 to dot 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 that much radian. Okay, then another possible value is what, this is the third one. Okay, because this is C, in the fourth quadrant sine theta is negative. So this is what, pi minus, sorry, 2 pi minus 2 times 3.1416 minus the principal angle which is 0.4115168 something. So this is point. Okay, this is sorry, this is 5.872 dot dot that much radian. We got the value for theta at R? No, not yet. We got 1, 2, 3. The first three we got. Now what? The fourth one. So fourth one will be what? We have rotated by 2 pi radian. Now we are again on the first quadrant. Here not possible because sine theta is positive in the first quadrant. Second quadrant not possible because sine theta is positive there. But in this third quadrant, after having a complete revolution, that is 2 pi radian, we can have another possible value for theta. What's that? This is basically what, 2 pi, and then we again rotated by half of a complete circle, which is pi radian. 3 pi, 3 times 3.1416 plus 0.411. Okay, So this gives you 9, okay, 9.835 that much radian. Okay, so which one we will consider? We will consider only the fourth one, and we will ignore the rest because the rest are for the first three, what? First three uh, points at the x-axis. Okay, now just find out the value for theta. Okay, so this is 9.836 if you consider the exact value. So 3 times 3.1416 over 8, it will be exact, is 6. So 3 times 3.1416 over 8 divided by 2, which is 5.507. 5.507 208.423 radian. Okay, so at R, the value for theta is equal to what? 5.5. How many decimal places they wanted, or significant figures they wanted? 3 significant figures. Okay, so up till 3 significant figures, that would be 5.51 radian. This is up to 3 significant figures. That's it. This is what they asked for, the value of what? R. And that's all about ninth question from January 2024 Geometrics 2 paper. That's it.